There it is. Okay, we're recording now. All right, so all right, I've got a couple of things that I'm trying to figure out. First of all right, we're going to talk some about this information, but for this week you're doing 10, 11, 12, and 13.
Yay!
All right, now, I found that this information was longer to be able to get through. Yes, Laura?
Are we going to be doing 6-14 as well, or are we skipping that?
This is what I have for the list.
Okay.
So 6:14 will be next week. We got another week after this in chapter 6. So, because there's a lot of information in there. All right, so this coming week, you're doing 10, 11, 12, and 13. You just had 3 last time. All right, you had 7, 8, and 9. All right, so that this is, now if you'll notice, you've got the even number problems here. This goes real fast. Those last 3 do not.
True. Yeah.
Okay.
Yeah.
Then the rest of these are relatively, but 13, when we're done, I've figured out how to teach that so that will go a little bit faster. There's a concept in 13 that I don't think is covered real well, and normally Forster does a good job at covering it, but his examples don't tell what I found to be the key. Okay? All right, now, so this quiz 10 I gave you, right? That's the long one, right? And then the other one is also on these chapters. So we're going to do that as homework instead of class time. Cool. All right, now, so then the question, we're looking for black. There they are. Okay. So here's my question. I can't do that from here. I can do that from here. Okay. So, what is a logarithm? What's a logarithm?
It's an exponent. That's the one thing that's.
It's an exponent. It's an exponent. Okay. All right. So, if I give you that the log of base 10 of some number equals an exponent, the logarithm is the exponent. So this is the base. That's the big number, and e is the exponent. It equals that number. Okay? So, and there are times when, in order to analyze it, you have to change the logarithm into its exponent form. Okay? So, if I gave you the log base 3 of 27 equals x, how do you change that into an exponent form?
3 to the 27?
All right?
I was going to say 3x equals 27.
What?
3 to the x power equals 27.
Very good. The base is 3, so that becomes the big number. The exponent is x equals 27, and that you should know.
This is the only kind of math I understand.
That is a tree, right?
Mm-hmm.
All right, because 3 to the 3rd power is 27.
And like finding the x.
Okay.
So
All right, does that make sense? So that's one of the skills that you need to be able to do, because sometimes you can't figure anything else out. Now, another thing that's important is whenever you have different bases, our calculators have base 10. All right? If you have a different base, okay, when you change that, what I want, the exponent is the log base 10 of the number divided by log base 10 of the base. All right, that's another switch, because your calculator can do that. So let's say that I give you this. Log base 4 of 28. Now, is 28 in the 4 times tables? Yes, but it's not a power of 4. The power of 4 to the second power is 16. 4 to the third power is 64. So this number will lie as an exponent of 4 somewhere between 2 and 3. Now, with your calculator, take the log of 28 divided by the log of 4. And you will get a number between 2 and 3.
2.4.
Okay. All right. So, now let's do this. Raise 4 to the 2 point, how many? Go 3 decimal places.
403.
403. Raise 4 to the 2.403 power, and you should have 27 point something. You don't have a calculator? Yes, you do, or no, you don't? You left it. You have a calculator, but you don't. You're welcome. Okay. All right. Did it work out? Okay. This skill is extremely important. On the power skills that I gave you, it's the one on the bottom. It's the one on the bottom. The other 3 are in the chapter that you're being assigned today for this week's homework. So I gave you all of those. Now, if you can understand what we're going to do next, a lot of the quiz problems for logarithms is involved in what we're going to do in the next 10 minutes. Okay? So that's where we're headed. But that's the first one. Okay, so now.
You got a touch screen.
Yes, I do. But I forgot my mouse, so I can't do it remotely. All right, I need a different thing here. Where is it? Bless you. Okay.
For a while, I was carrying around the mouse,
So-
but I don't think I have it now.
Okay, so here's the first skill that we're going to talk about, and it's called the log of a product. All right, now, if you have to some base some value n times m, because these are the answers, b to the n power, the log of b to the n power plus the log of b to the m power, or the m value, becomes the answer. So for instance, what is the log of 10? Put that in your calculator. Do log of 10. What do you get? 1. Why? Because 10 to the first power is 10. Okay, now here's what I want you also to do. Put log 2 plus log 5 in your calculator. Log 2, close parentheses, plus log 5. 1. Because 2 times 5 is 10, because the product is 10, then what I have is this, is I have base to the n, and then base to the m. How do I combine them? I add them. That's why that's added. Okay. Now, there's a lot of cool things that we're going to do with that. All right. So, whenever you see a value here, you can break it into any two products that you want. You can break that into any 2 factors, and then take whatever this base is. Right. Take the log of that base to one of the factors plus the log to the other factor. All right. We're going to do that in just a minute. Okay, so that's for products. Okay, what about this? Log of quotients. All right, whenever you have x to the a and divided by x to the b, what do you do with the exponents? Subtract. And subtract, right? Now, same thing. We know that the log base 10 of 10 is 1. Here's what I want you to do. 20 divided by 2 is also 10. So take the log of 20, subtract the log of 2. So what else could you use? Could you use 40 divided by 4? Take the log of 40 divided by the log of 4.
Minus or 5.
Oh, I'm sorry, subtract. Because it's 40 divided by, so subtract, thank you.
1.
It's still 1, right? Okay, now, had I had a different number than 1, because I would have changed this, the principle is still the same. Okay, now, the last one, third one, is the log of a power. All right, you see this m right here? This m comes to the outside. Because I have m in number, I have this many logs of those. Right? And a quick way to add is to multiply. Right? And so this becomes the value here. Now where we're going to use this, okay, see this is log base of 2 to the third power. This exponent comes out here and it's 3 times the log of 2. Okay? Now, do 3 times the log of 2 in your calculator.
Equals log of 8.
Hmm?
It equals log of 8, except it doesn't say log of 8.
No, but I want you to get the value
Yeah,
of 3 times the log of 2.
0.903.
Point
903.
No, it's 0.9.
Sorry.
0.903 what?
1.
1 what?
That's it. That's all they give me.
Oh,
I got,
gee, what do you
So
get
I
on that?
got a little more.
I got 3089987.
Alright, try to say it again. Point.
So point
have the same thing.
9030899.
89, that's good.
Yeah.
Okay. Alright, now take the log of 8 and compare it with that number.
It's the same one.
Wow.
Magic.
Okay. Alright, so what we've done is on this handout, we've just gone over those 4 items. Okay. See that?
Yes.
Yeah, is this it? Okay, so now I'm done with that one. So now I can kill it if it'll go. And then, okay. Alright, turn to page 278 in your textbook. 278 in your textbook. Okay, now I'm hoping that we can do this orally. All right, but if you're not thinking along with me, then the oral work is not going to help you. All right, so first of all, if we look at this, I give you the log of 2, the log of 3, and the log of 5. Okay, what do you see in problem 11 on 279?
It's log of 2/3.
2/3, that's the log of 2 divided by
The log of
3. Okay, so if the logarithms are divided, what do I do with the values? Subtract. So it will be this minus that.
Whoa. I love my life.
See? Now that's this, for a logarithm skill, this tests whether or not you know what to do with that fraction. So instead of putting the fraction in, because this would be a non-calculator assignment. Okay, so, and normally part of your test is with a calculator, part of your test is without. If you were doing a test with a calculator, there's something that you can put in. But if you're doing it without, you're going to take log of 3, subtract log of 2, and so it's going to be, you know, 0.16 something or 0.176. Okay? But what I want to know is whether or not you can see what to manipulate in order to be able to get what's in the book. Yes, Hannah?
Wait, when it's 2/3, it's log of.
Oh, 2, I'm sorry.
That's
So
log of
yeah,
2
it'd be
minus.
this, subtract that, yes.
Okay,
I'm sorry.
Thank you.
I didn't look at it closely enough.
Just making sure.
Okay,
Yeah.
I was looking at 12. I was looking at 12. So problem 13. Problem 13 is a 10. How do I get 10 if this is all I've got?
It's just one.
No, how do I get a 10?
You multiply 5 times 3. 5 times.
So this
Oh, wait.
plus this will be the same as log of 10 in that base.
That's
All right. Now, what about 15? How do you get a 15 with this information? Log, it's this plus this, so I'm going to add this plus that. Make sense?
Yes.
All right, now, 17 says log of 3 to the 6th power. What happens to that little 6?
It goes to the.
It comes where? It comes outside. So it's going to be 6. It's going to be 6 times.
log of 3. That's so.
Isn't that easy?
Yes.
Okay. All right. So now, what about problem 19? 2 ways to do this. Problem 19. All right, 100 we don't have, right? What's 100 though?
10 times
10 times 10. So this is 10 to the 2nd power, right? So I'm going to want 2 times the log of 10, which is this plus that.
Twice.
Yes. So it'd be parentheses, well, 2 parentheses. Come on. 2 parentheses. 0.301 plus 0.699. And that comes pretty close to 1 times 2, right?
Yeah.
Okay? All right, so what about 23? Yeah, really tricky. 23 is what number? Isn't it 30?
Yeah.
What product can I use?
Oh.
Break it apart.
3 and 10?
3 and 10. Okay, 3 is here,
Yeah.
plus
5.
5. So it's this plus that. Okay, that's all it is. Okay? All right, and then when you get to the second section on 279, you're doing the reverse. Okay, look at 33. If they added those logarithms, then what number did they begin with? 5 times 7. Which is 35. This started out as the log base 3 of 35, and they split the 35 into 5 and 7. Okay? All right, look at number 35. All right, what does the minus sign mean?
Division.
Divided. So it was 24 divided by 8, which is tree. Right? Only they made the 3, 24 divided by 8, and then subtracted them. All right, so 37, what do you see? You see plussing, right? Adding, right? So if there's a plus sign, what does that mean that happened to the numbers? Multiplied. So what numbers are you going to multiply together? 2 times 5 times 3, which is 30. Okay, now 39, what do you say?
48 divided by 12 times 4.
Right, 48 divided by 12 times 4. So 48 times 4 divided by 12.
Yep.
And whatever that number is. Okay, 41. You see the 5 in the front? It was what? It was an exponent of the 2. So it's log base 12 of 2 to the 5th power, which happens to be 32. Now, 43 is what you normally see because it's the most complex. All right, you see the 3? Where does it go? It would be what? 15 to the 3rd power. And what about the minus 25?
That would be
Divided by 25. So, if I can, come on, wake up. Is there? There we go. So, you would have 15 to the 3rd power divided by 25. Whatever that number is.
Right.
Again, I'm glad I have a calculator, so I hate to do that one by hand. Okay? All right, so Any questions on that? All right, now, go to 45. This is important. Where is the exponent on 45? Where's the exponent? It's the x, right? Okay, let me see. I've got a blank screen here, so I want to work on this. Okay, now, so it says 17 to the x equals 4.7. 17 to the x power equals 4.7. In order to be able to get at the x, what I'm looking for is log base b of b to the x equals x. Because this power comes out to the front, right? And then log base b of b is 1. Okay? So, in order to be able to get to this x, what log base do I need? I need this log base, which is what? 17. So I'm going to do log base 17 of that number, and here I'm going to have log base 17 of 4.7. Now, by definition, this is how I get to the x. Now, are those bases the same thing we have in the calculator? No. Okay, look at, on your paper, look at number 4. In order to be able to get this in logs that we have, I'm going to take the log of the n and divide it by the log of the 17. So that makes this log of 4.7 divided by log of 17. All right, now, you have to see that. Who does not understand what I just did? Okay. What does number 4 say? Log of what? Base n of m, right, equals log in base 10, which is our calculator, of m divided by log in base 10 of n. So whenever I have this here, log 17 of 4.7, I don't have anything in the calculator I can do. But I do have a way to transform that. I take the log of the number and divide it by the log of the base in base 10. So that's going to be the log of the number divided by the log of the base. Put that in your calculator. 5462217. Right?